All right, for now this one, the work that we're gonna do today, it was created by this French philosopher. Let me write his name. Let me spell it out first. Let me write this thing out. Keep in mind, he was French, so the way we read this is Descartes. I know people want to read it differently, Descartes or something like that, but no, we read it as Descartes. He was French. Now, one thing that he said is, looking at the graph, we've been talking about how to find the zeros, right? Where do I cross the x-axis? That's basically a zero. Where do I cross the x-axis? He came out with a formula. He thought of this thing. He's like, well, there's the x-axis and there's the y-axis. One thing is that he can focus on the right side of the x-axis. So the graph could look something like this, right? He could be crossing the x-axis multiple times. He said, I'm going to be looking at f of x, and I'm going to see how many times, because he noticed that from above the x-axis to below, or from below to above, it went from positive to negative or from negative to positive. So he's like, I'm going to see how many times does the sign change, right? Positive to negative or negative to positive. I'm going to be looking at f of x, and I'm just going to look at the change of the signs. But then he figured, what if I look at the left side of the y-axis? In this case, he was looking at f of negative x. And again, he's just going to be looking at the signs, because I could cross the x-axis this way, right, from the positive to the negative, or from the negative to the positive. We're going to look at both cases, and then we're going to see. Okay, so if that didn't make sense, let's take a look at this way. I'm going to be looking at, it says the possible number of real solutions. So let me take a look at the real solution, the possible numbers of real solutions. I'm going to be looking at the signs. I'm just going to be looking at the signs of my terms of f of x. So I have a positive, I have a positive, I have a positive, 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 and positive. So it seems like the sign never changed, right? So I'm gonna say, according to Descartes, on the right side of the equal sign, on the right side of the y-axis, this thing will never cross the x-axis, right? It didn't change signs. Now let me think of f of negative x. So I'm gonna have negative x all to the fifth. So instead of an x, I'm gonna use a negative x, use parentheses if necessary, plus 5 negative x to the fourth, plus 6 negative x to the third, plus 30 negative x to the second, plus 5 times a negative x, and plus 25. Again, instead of x, I wrote negative x. Use parentheses if necessary. Now, one interesting part with negative signs, when my exponent is an odd number, 1, 3, 5, odd numbers. So here, for example, my first term, when my exponent is an odd number, I do keep the negative sign. So it's going to be negative x to the fifth. Right? When the exponent, again, is an odd number, the answer ends up being negative. If you don't believe me, multiply a negative number, like negative 3, for example, 5 times, and you're going to see that your answer is negative. When the exponent is even, so I'm looking at this second term, when the exponent, so let me highlight the exponent. When the exponent is even, because you have an even amount of negatives, they cancel out, so it becomes a positive 5x to the fourth. When my exponent is even, the negative sign goes out. When my exponent is, when my exponent is odd, my negative sign goes out. When my exponent is even, the negative becomes positive. So now here on the third term, my exponent is odd. So my negative goes out. Here, my exponent is even. So it becomes positive 30x squared. And then minus 5x plus 25. Okay, so let me take a look at the signs only. Negative, positive, negative, positive, negative, positive. All right, there were a few changes, right? There was a change right here from a negative to a positive, from a positive to a negative, from a negative to a positive, from a positive to a negative, and a negative to a positive. There were a total of 5 changes. So on the right side of the y-axis, this function is going to cross it can cross the x-axis 0 times. On the left side of the y-axis, it can cross it up to 5 times. So by the numbered real solutions, let me add these two numbers. These numbers that I had in parentheses. So I'm looking at these numbers. Let me add those numbers. So I'm going to say the possible number of real solutions going to be 5. The maximum it could be 5 because I added those numbers. Or it could be 3. Or it could be 1. So I'm going to add the numbers in parentheses. That's going to give me the maximum. And then for the next number, I'm going to subtract 2. So notice I went 5, I went to 3, I went to 1. I'm going to subtract 2, but I cannot get to negatives, right? If I continue here, I get 2 negatives, so no. So you're going to stop once you hit either a 1 or a 0. Now, that's the amount of the possible number of real solutions. Now, I can also ask, what's the amount of imaginary zeros? Now, imaginary zeros, that's when we're going to have the square root of a negative. I'm going to use the highest exponent on my function, and I'm going to use my smallest possible real. So again, I use the highest exponent. I use the smallest possible real. I'm going to subtract those. 5 minus 1 is 4. So I'm going to say the maximum amount of imaginary zeros is 4. Or it could be 2, or it could be 0. Notice how I started at a numbered, and I kept on subtracting 2 until I hit either 1 or 0. Your homework, I'm going to ask only for the possible real solutions. And you guys will have to click on boxes 5, 3, or 1. Or I can ask for imaginary solutions, imaginary zeros. Now, if I ask you for the imaginary zeros, you do have to get the real zeros anyway. Because notice how for me to find out what's the biggest amount of imaginary zeros, I went the highest exponent minus the smallest real. So you do need to know how many real possible solutions you can have. All right, let's do another example. Let's take a look at number 30. I'm going to look for how many possible zeros. With f of x, I'm just looking at the signs, positive, negative, and negative. There was one change here. And once again, a change means from positive to negative or from negative to positive. So I'm going to say there was one change. So that means on the right side of the y-axis, this function can cross the x-axis once. So again, from the right side of the y-axis, I can cross the x-axis once. Now, let me think of f of negative x, because I need to worry about the left side of the y-axis. So f of negative x is negative x to the 4th minus a negative x to the 2nd minus 30. And I said earlier, if the exponent is odd, the negative comes up to the front. If the exponent is even, then the negatives become a positive. So this is x to the 4th. This minus has nothing to do with my parentheses or my exponent. Here I have x to the 2nd. It became positive x to the 2nd because my exponent was even, and then minus 30. Let me think of my signs. positive, negative, negative. There was one change. Okay, so on the left side of the y-axis, I can cross the x-axis once. When I add my two parentheses, the maximum of possible real solutions, I'm going to say, is 2 or 0. Notice I started at 2, and then I kept on subtracting 2 until I reach either 1 or 0. Now for imaginary, I'm going to use my highest exponent and my lowest 0. So I'm just going to go 4 minus 0 gives me 4. So the maximum amount of imaginary solutions is 4 or 2 or 0. So I started at 4, I kept on subtracting 2 until I reach either 1 or 0. But notice that for my imaginary real zeros, I needed to know the smallest real 0. So even if I ask you just for the possible amount of real solutions, just get the real solutions. If I ask you for the possible number of imaginary zeros, you still have to get the real zeros in order to get the imaginary zeros. All right, let's take a look at number 31. When it comes to signs of f of x, I have positive, positive, negative. There was one change right here. So one change. Now let me think of f of negative x. That is negative x all to the fourth plus 2 negative x to the second minus 48. So this is going to become positive x to the fourth. Becomes positive because my exponent is even, plus 2x to the second. Became positive x because my exponent was even, minus 48. Okay, when it comes to the signs, this is positive, positive, negative. There was only one change here. So when I add those numbers that I have in parentheses, 1 plus 1 is 2. So I either have 2 or 0 real solutions. So when it comes to real solutions, it's either 2 or 0. When it comes to imaginary, I'm going to go 4 minus 0. My highest exponent on my function minus the smallest real. 4 minus 0 is 4. So when it comes to imaginary, I start at 4, 2, or 0. This is imaginary. I needed to know the real solution. Again, on your homework, I might ask just the real solution, so just 2 or 0, or just the imaginary. If I ask for just the imaginary, you have to get the real zeros anyway. All right, let's take a look at this one. According to Descartes, let's see, this is positive and this is positive. There is 0 times the sign changes, right? Positive, positive, it did not change. So 0 changes. So that means on the right side of the y-axis, I will not cross it. I will not cross the x-axis. Now let me think of f of negative x. So I have negative x all to the third plus 64. My exponent is odd, so the negative does come out. Negative x to the third plus 64. Let me take a look at the signs. Negative, positive. There was one change. So when it comes to real, the maximum amount of real zeros that I can have is 1. Not going to subtract 2 because remember I have to stop once I reach 1 or 0. Now, if I'm asking for the imaginary, I'm going to start at 2. Remember, I went the highest exponent minus the smallest 0, which obviously was 1. So 3 minus 1 is 2. So my highest imaginary is 2 or 0.